Hi everyone, in this lecture we are going to talk about fancy indexing. I have imported NumPy as NP and matplotlib.pyplot as PLT. And now it is time for us to take a look at this folder, data. Within here we have this gpd_pc file, which is going to give us the gross domestic product for a range of countries. So I think we have already talked about the salaries CSV. Now we are going to talk about the GDP, gross domestic product. Now I'm going to say GDP. This is going to contain the GDP for the year 2016. That's why I'm going to basically call it GDP 16. We are going to grab pandas as well, so let me import pandas as well. We are going to use the pandas read CSV API to read in all the values from the CSV. So pandas as PD. In here I'm going to say read, so we are familiar with this method, read CSV. Where is that? It is within the same directory. So there is a folder in this directory. The name of the folder is data. Within there, it is gdp_pc.csv. Now from this data, I just want to grab, there is going to be two columns. I want to grab the column 2016 and all the values from there. So it's gdp_16. Let's run it. So these are all of our data in here. Let's take a look at the type of GDP 16. I'm going to copy this because we are going to use it a lot. So I'm going to say type. It is a NumPy n-dimensional array because the second dimension is missing. If I were to take a look at the shape of this, it is just going to return a tuple with one item. So if I say gdp16.shape, this is going to just give me like 264. Why is it like the second item is missing? Because we just grabbed one column from there. We just said that it should be like a one-dimensional array, and that's why there is only one bracket in here. Let's visualize this data using matplotlib. In this case, the plot function takes in a NumPy array. So I'm going to say plt.plot. And let's pass in the NumPy array, and then we are going to say plt.show. Let's run that. There we go. So this is the graph for this PLT, for this GDP data. Let's try to find the median, np.median. Let's pass in that data. If we run it, we are going to get NaN, or not a number. The GDP data contains missing values. That's why NumPy was unable to calculate the median. Where are the missing values? Here it is, NaN. So there are almost like 30, 40 values which are actually missing. So let's say we want our GDP NumPy array, GDP16 NumPy array, to contain data only for those countries where the GDP value is not missing. We can do this using fancy indexing. So I'm going to say fancy indexing. All right. So we can do, we only want data that we only want to get the median for the GDP for the countries that actually exists. So I'm going to say GDP_16. Let's grab the GDP 16. Keep in mind, we are indexing, so we are going to use the bracket notation. It is fancy indexing, and fancy refers to something fancy that we're going to do inside of it, but the indexing idea is the same. We are going to use brackets. So here I'm going to use the Python tilde operator. I'm going to say np dot. I'm going to remove it first. I'm going to say as NaN, which I think we have talked about before, and I'm going to pass in GDP. Now this is going to grab all the values which are NaN, but that is not what we want to do. We want to find the median for the countries that do have GDP. If it returns all the NaN values, it means that those countries do not have any GDP, right? So we need to flip the meaning of this is NaN. We need to flip it. We need to say that we do not want is NaN. We do not want NaN. So for that, anything that is going to flip the operator that is going to flip the idea or the concept of this is SAN. SAN is basically a negative concept. It says that I want the values which don't exist. It's negative, right? But when you flip it, it's going to become positive. I want the values which are not NaN. Like there is a not there. This is a bitwise negation operator. It takes the number and in whatever it is that we are trying to flip it, and flips all the bytes from 0 to 1 and from 1 to 0 to obtain the complement binary number. All right. So basically what this is going to do for us is give me all the numbers which are not NaN. Let's grab GDP, and now if we take a look at it, there is no NaN value. So doing that, we can take a look at the shape first. So we have 229. What did we have before? 264. So it's almost 35. So it's 35, right? 35 values were NaN. Let's find the median. np.median. Let's pass in that. We're going to get 13113.97. That is the median. We can calculate the mean as well. np.mean. Pass the array. Keep in mind that all these methods, all these functions, they grab a NumPy array, right? GDP underscore 16. That's why we take a look. We took a look at the type of it. The type was n-dimensional array, right? That's why it works. It has to be an array. Now we can take this indexing up a notch by providing conditional indexing. For example, if I say np.count underscore non-zero, and I'm going to pass in that data, and we are going to say, okay, give me all the data for the GDP which is greater than 40,000. So this condition, the condition is provided as an index. If I run it, there is 32. So there are 32 countries that have GDP which is greater than 40,000. We can sort the array as well. For that, we're going to say np.sort. Let's pass in GDP. And what do we want? When we sort it, we want to grab the first 10 items, right? So we are going to say 0 to 10. Now this sorting, the order is going to be ascending. Ascending starts from smallest, goes to the biggest. So we are going to see the 10 smallest numbers. There we go. So these are the smallest GDPs. We can, let me just give you another example as well. So I'm going to say sort in a different manner. Let's pass in the array, and now let's say I want to grab all the items starting from index 219 and to the end. There we go. So these are all the index. So there are going to be like 10 because we have actually specified that we want the NaN to be taken out of here. All right. We have actually changed our n-dimensional array, and we have taken out the NaN values. That's why when I say 219, you're going to get 10. Because 10 plus 219, you're going to get 229. There we go. So we can also use conditional indexing. Conditional indexing is whenever you provide conditions within the index. We have already done that right here, but we have actually counted the non-zero values for that. All right, so let's just do like very simple conditional indexing. I want to say give me all the GDPs which are greater than 6570.6. These are all the GDPs which are greater than 6570.6. We can count all the non-zero numbers, and we can provide a condition there as well. So you can say, if I say count non-zero, let's pass in the array, and then basically count all the non-zero numbers which are greater than this number. We're going to get 152. We can flip the condition to count the remaining records. And if you combine both of them, they should be 229. So if I say in p count non-zero, flip the condition, provide the array, flip the condition so it's less than 6570.6. Run it. 77 152, that's 229. We can write more complex conditionals as well, like count non-zero. Give me all the GDP which are greater than 6570.6, and we are going to do the AND operator, okay, ampersand, the AND operator, and give me all the GDPs which are less than 16609.7. So how many GDPs are there? It is going to give us 60 GDPs, which are greater than 6570 and less than 16609. That's it for this lecture. See you in the next one.